This video will talk about electricity and magnetism and how they relate to each other. When we talk about this topic, a very important person we should talk about is Hans Christian Oersted. He was a Danish physicist and a teacher who was born in 1977, and he discovered that electricity and magnetism were linked through an experiment that we're going to be recreating. So what exactly did he do in his experiment? So he passed an electric current through a wire, and this is what caused the compass needle to move. This happens because the wire carries a current that creates a magnetic field around itself, which is why the magnetic field is circular. So when you bring the compass near the wire, this is what causes the compass needle to move. Another important thing to know when recreating his experiment is that depending on where you locate the compass, the needle will be moving towards a different direction. We also have the right-hand rule. This is used to determine the direction of the magnetic field. In order to do this, you take your right hand and you hold the wire pointing your thumb up in the direction of the current. Then your curled fingers will be the ones pointing the direction of the magnetic field. My objective is to successfully recreate Oersted'S experiment and prove his theory. And my hypothesis is that I will be able to recreate Oersted'S experiment and see how the compass needle moves. The materials for this experiment are a wire, a compass, and a battery. In this case, I'm going to be using a 9-volt battery. As I mentioned earlier, the needle will move according to where the compass is placed, which is why we're going to have two different setups. In the first setup, the wire will be on top of the compass, and in the second setup, the wire will be behind the compass. Once we have the setup, in order for the experiment to work, we have to take the two ends of the wire and place them on the battery. So as I mentioned before, I did two experiments, and I started out by the one where the wire is on top of the compass, and as you can see, it did move to the right, and then when I did the next experiment, it moved to the left. After finishing our experiments, we can conclude that we did in fact do it correctly, and we can also agree with Oersted's law, which is that an electric current produces a magnetic field. And that was the end of my project. Thank you!